Welcome to our Knowledge Bank series, where we uncover the invisible threats in the air around us, pollutants that impact our health and environment. Have you ever noticed a burning smell in the air, or wondered why some monuments slowly wear away over time? It might be due to sulfur dioxide, or SO2, a gas that's often invisible but leaves a lasting impact. So, let's understand what SO2 is. Sulfur oxides, gases formed from sulfur and oxygen, are more common in the air than you might think. Sulfur dioxide, SO2, is a major air pollutant released from burning fossil fuels, industrial activities, and natural sources like volcanic eruptions. While often invisible, SO2 has serious consequences. It can cause respiratory problems, irritate the airways, and contribute to acid rain, which damages ecosystems and infrastructure. Because of its harmful effects, SO2 is one of the 6 criteria pollutants regulated under the Clean Air Act to protect public health and the environment. Now, let's explore the sources of SO2. Sulfur dioxide is released into the atmosphere from both natural and human activities. While it exists in trace amounts naturally, human activities have dramatically increased its presence in our air. Its natural sources include volcanic eruptions. When magma rises to the surface, pressure decreases, causing sulfur compounds to mix with other gases. These emissions can reach the stratosphere, interacting with water vapor, leading to acid rain formation. Burning of fossil fuels such as coal, oil, and diesel is a major contributor to SO2 emissions. The filtration process in power plants and industries often determines how much SO2 is released into the air. Industrial activities like oil refining, metal extraction, and aluminum smelting also release significant amounts of SO2. Even transportation, especially ships, locomotives, and heavy-duty vehicles burning sulfur-rich fuels, plays a role in increasing SO2 levels. After exploring the sources, let's take a closer look at the health impact of SO2. Sulfur dioxide, SO2, might be invisible to the eye, but its impact on health and the environment is impossible to ignore. SO2 plays a major role in air pollution. SO2 is more than just a gas, it's a respiratory hazard. When inhaled, it irritates the mucous membranes of the eyes, nose, and throat, causing discomfort and breathing difficulties. Short-term exposure can lead to coughing, mucus production, and airway inflammation. But for people with asthma, children, and the elderly, even low levels of SO2 can trigger severe respiratory issues. Prolonged exposure increases the risk of chronic bronchitis and cardiovascular diseases. Let's move forward and understand its impacts on the environment. SO2 disrupts entire ecosystems. One of its most damaging effects is acid rain. When SO2 combines with moisture in the air, it forms acidic compounds that fall to the earth as acid rain, harming soil, plants, and aquatic life. It weakens trees and slows plant growth, damaging forests and agriculture. It makes the water toxic, threatening fish and other aquatic species. It even alters soil composition, reducing fertility and affecting food production. It also stains and corrodes historic monuments and buildings, damaging cultural heritage. To stay safe from SO2 exposure, it's crucial to take timely precautions. Here are a few simple yet effective steps. Switch to renewable energy like solar, wind, and hydroelectric power to cut SO2 emissions at the source. Install scrubbers in power plants. These devices filter out SO2 before it enters the atmosphere, improving air quality. Avoid high pollution areas, especially for sensitive groups. Staying indoors during peak pollution hours can help reduce exposure. Industries can lower sulfur in transportation fuels. It cuts SO2 emissions and reduces other harmful pollutants. While individual actions help, large-scale change depends on better monitoring and regulation. Let's explore how air quality monitors measure SO2 in the atmosphere. Several monitoring techniques are available to track SO2 levels in the environment. UV fluorescence. It is a widely used method that works by exposing SO2 molecules to UV light. The molecules emit fluorescence, which is detected and converted into an SO2 concentration reading. Semiconductor sensors. These sensors use metal oxide films that react with SO2 molecules, changing their electrical resistance. The variation in resistance helps determine the gas concentration, though this method requires high energy consumption. Electrochemical sensors. In this method, SO2 diffuses into the sensor and triggers an electrochemical reaction, generating an electric signal proportional to its concentration. This method is highly accurate for detecting even low SO2 levels in ambient air. By learning more about it, monitoring it, and taking small steps to reduce exposure, we'll invest in healthier communities, a cleaner planet, and a better future. We hope this gave you a deeper understanding of SO2 and its importance. If you have questions or want to explore more, we're always here to help. Stay informed, stay safe, and keep breathing clean.